the early 2000s, Boeing made a $32 billion gamble on a material the industry had never used at scale. That gamble eventually paid off, with issues, sure, but few could argue that the 787 is not a successful program. You're looking at the 787 Dreamliner, the aircraft that rewrote the rules of commercial aviation. But what you don't see are the engineering secrets hidden beneath its composite skin. How did a plane that suffered years of delays and production disasters become the most advanced passenger jet ever built? And why do its wings bend over 25 feet during flight, on purpose? The Dreamliner harbors quirks that even frequent flyers rarely notice, from windows without shades to brakes that predict their own failure. I'm about to show you 10 extraordinary secrets of the 787 that will transform how you see this aircraft. They all connect to one revolutionary decision that changed everything. Let's start with those wings. Quirk 1. Wings that flex over 25 feet. Watch a 787 during takeoff. The wingtips arc upward like they're reaching for the sky. But Boeing tested these wings by bending them up to 150% of the maximum load they'd ever see in flight. They flexed them over 25 feet upward before the test article finally failed. During certification in 2011, Boeing bent one wing upward nearly 26 feet at the tip, far beyond anything it will ever see in service before the structure gave way. That's roughly the height of a telephone pole, and the wings held well past any real-world scenario. Why build wings that flex this much? Two reasons: weight and turbulence. The 787's wings are made from carbon fiber reinforced plastic. Carbon fiber is lighter than aluminium and can stretch almost twice as much before breaking. That extra flexibility isn't a flaw, it's the feature, and it's only possible because of composites. When a gust hits the wing, instead of transferring all that force straight into the fuselage and the passengers' stomachs, the wing absorbs it. Boeing's engineers designed the wings to flex during normal flight, not just during stress tests. On a typical climb, you'll see several feet of deflection. The wings are designed so their optimal aerodynamic shape occurs during cruise, not on the ground. On the tarmac, they sag slightly. At altitude, under load, they curve into the perfect position. The plane is literally built to perform best when it's flying, not sitting still. Because carbon fiber doesn't fatigue like metal, these wings don't need the same level of inspection. No metal fatigue means fewer cracks, less downtime, and longer service life. But the flexibility is just the beginning. That same material choice enabled something passengers actually notice. Quirk 2. Windows that dim themselves. No window shades. None. Look around a 787 cabin and you won't see a single pull-down shade. Instead, there's a button below each window with 5 settings, from crystal clear to near blackout. The tech is called electrochromic dimming. When you apply an electrical current to a gel sandwiched between the window panes, the gel darkens. The higher the voltage, the darker it gets. No current, fully transparent, and the crew can override you. There's a master control up front that lets flight attendants lock the windows at a specific tint level. Why ditch the shades? Weight, maintenance, and aesthetics. Window shades break, they jam, they get torn off by passengers. Plus, even at full dark, you can still see outside. It's not a blackout curtain, it's more like wearing sunglasses. And these aren't small windows. The 787 has the largest windows of any commercial widebody, 30% bigger than a 777's. More view, more natural light, and a greater sense of space in the cabin. But there's something even more invisible happening that your body will thank you for. Quirk 3. You're breathing better air. Most planes pressurize the cabin to simulate 8,000 feet above sea level. The 787, 6,000 feet. That's a 25% improvement in air pressure, and it makes a real difference on long flights. At 8,000 feet equivalent, your blood oxygen saturation drops. You get more tired, more dehydrated, and jet lag hits harder. At 6,000 feet, most of those symptoms reduce significantly. Why don't all planes do this? Maintaining higher cabin pressure at cruise altitude means more stress on the fuselage. Every flight cycle, the plane inflates and deflates. Over thousands of flights, that causes metal fatigue. Aluminium fuselages can't handle the extra stress without being heavier and more expensive. But the 787's composite fuselage, it doesn't suffer from metal fatigue. So, Boeing could crank up the cabin pressure without worrying about the airframe giving out. The 787 also runs higher humidity, around 15% instead of the typical 6 to 10%. Your skin doesn't dry out, your throat doesn't get scratchy, and you're less likely to feel mummified by the time you land. There's also an advanced air filtration system that removes odors, bacteria, and allergens. Fresh air is drawn directly from outside the aircraft, not bled off the engines. Add it up and you've got lower cabin altitude, higher humidity, better filtration. On a 14-hour flight, your body absolutely notices. And speaking of things you don't notice, Quirk 4. The engines have teeth. Look closely at the back of a 787 engine and you'll see a sawtooth pattern at the end of the nacelle. Those aren't decorative, they're chevrons, and they exist for one reason: to shut the engines up. Jet engines are loud. The noise comes from hot exhaust air from the engine core mixing with cooler air from the bypass fan. When those two streams collide, they create turbulence, and turbulence creates noise. Chevrons smooth out that mixing. Instead of a chaotic collision, the serrated edge forces the air to blend more gradually. Less turbulence equals less noise. NASA and Boeing spent years testing different designs before landing on the chevron shape. The result? The 787 is up to 15 decibels quieter than comparable planes. A 10 decibel reduction cuts perceived loudness in half. The 787's noise footprint is 60% smaller than the 767, letting it operate out of noise-sensitive airports with almost no restrictions. Airports love this. Noise regulations keep getting stricter, and quieter planes mean fewer complaints from nearby communities. Some airports have curfews or noise penalties, so reduced engine noise directly translates to operational flexibility for airlines. Passengers benefit too. A quieter engine means a quieter cabin, which makes it easier to sleep on long flights. But the quiet engines tie directly into the next quirk, maybe the biggest engineering leap on the entire aircraft. Quirk 5. It runs on electricity, not air. Most jets run critical systems using bleed air, hot, compressed, trapped air off the engines. It powers cabin pressurization, air conditioning, and anti-icing systems. The 787 doesn't do that. It's the first commercial airliner with no bleed architecture. Instead of pneumatic systems, almost everything runs on electrical power: cabin pressurization, electric compressors, wing anti-icing, electric heated blankets, hydraulic pumps, also electric. Why go electric? Well, efficiency. Bleed air systems are energy hogs. Extracting air from the engine compressor robs thrust and burns extra fuel. Electric systems only draw the power they need, and when they need it. Boeing's data shows the no-bleed architecture extracts 35% less power from the engines. That translates to about 3% fuel savings. Fewer pneumatic ducts also means less weight. Hundreds of pounds of titanium piping, valves, and manifolds all gone. Simpler systems means less maintenance. The 787 has 6 generators, 2 on each engine and 2 on the APU. Together, they produce 1.45 megawatts of electrical power, about twice what older planes generate. Because there are no hot bleed air ducts to crack, the 787 has fewer unscheduled maintenance events related to environmental control and anti-ice systems. But all that electrical power enables something passengers actually feel. Quirk 6. A noticeably smoother ride in turbulence. Everyone who flies the 787 regularly says the same thing: turbulence just feels milder. That's not an accident. Boeing combined 3 things that work together: composite wings that absorb gust energy instead of slamming it into the cabin, an active gust load alleviation system that instantly deflects spoilers and ailerons the moment it senses aircraft movement, and the lower cabin altitude that keeps your body from getting extra stressed in chop. The result? Boeing's own study showed a dramatic reduction in motion sickness incidents. Pilots and cabin crew consistently rate the 787 as one of the smoothest riding widebodies in the sky. You'll still feel big turbulence, physics doesn't negotiate, but the sharp jolts that make you grip the armrest on a 777 or A330 are noticeably dulled on the Dreamliner. Quirk 7. Double bubble fuselage. The 787 isn't a perfect circle in cross-section, it's 2 circles stacked. one larger for the cargo hold, one smaller for the passenger cabin. This creates more vertical space, which means taller ceilings and more shoulder room, even though the plane is narrower than a 777. Walk down the aisle and you'll notice the ceiling doesn't curve down as aggressively. Traditional fuselages force a compromise. You either maximize passenger space and sacrifice cargo volume, or vice versa. The double bubble design optimizes both. The lower lobe is sized specifically for standard cargo containers, maximizing freight revenue without cramping the passenger cabin above. It also allows crew rest areas to be installed above the passenger cabin. On ultra-long-haul flights, the 787 uses the space above the ceiling in the aft section, accessible via a hidden stairway near the galley. This keeps valuable cargo space open. The two circles share a common wall at the cabin floor, which strengthens the entire fuselage without adding weight. That strength is critical for handling the higher cabin pressurization we talked about earlier. Quirk 8. LED mood lighting that fights jet lag. The cabin lighting isn't just for ambiance, it's specifically tuned to your circadian rhythm. The 787 was the first commercial aircraft to use full-spectrum LED lighting throughout the cabin. These LEDs can produce millions of color combinations, and each airline programs custom lighting sequences for different phases of flight. Your body's internal clock is regulated by light exposure. Blue-rich light signals daytime and keeps you alert. Warm amber light signals sunset and prepares your body for sleep. Airlines use this to help passengers adjust to new time zones faster. On a westbound evening flight, the lighting simulates a gradual sunset, shifting from bright white to warm amber to deep red. On an eastbound red-eye, the sequence reverses, dim and warm at first, then gradually brightening to a cool, energizing blue as you approach your destination. Boeing worked with sleep researchers to develop these sequences. The LED also lasts longer and uses less power than traditional bulbs, rated for about 20,000 hours of operation. Quirk 9. Raked wingtips that rewrite aerodynamics. Instead of winglets pointing up, the 787 wingtips sweep back in a smooth, elegant curve. This isn't just an aesthetic choice. Raked wingtips reduce drag more effectively than traditional vertical winglets, while also cutting weight. Here's the physics. When air flows over a wing, high pressure below tries to curl around the wingtip to reach the low pressure area above. This creates a vortex, a spinning column of air that trails behind the plane. Vortices create drag, and drag costs fuel. Vertical winglets disrupt those vortices, but they add weight and create their own drag at the attachment point. They also increase the bending load on the wing root, which requires stronger and heavier structural supports. Raked wingtips solve this differently. By sweeping the tip back instead of up, they spread the vortex disruption over a longer span. Same drag reduction, less structural penalty. The raked tips also raise the wing's natural flutter speed so high that Boeing didn't need heavy flutter dampeners, saving hundreds of pounds per aircraft. Boeing's wind tunnel tests showed that the raked tips improve fuel efficiency compared to older wingtip designs. Over the life of the aircraft, that's millions of dollars in fuel savings per plane. Quirk 10. Brakes that diagnose themselves. Most 787s now use electric brakes that monitor themselves in real time. Traditional aircraft brakes are hydraulic and have no idea how worn they are until a mechanic physically inspects them. The 787's electric brakes have built-in sensors that measure wear, temperature, and braking force continuously. The flight computer tracks every landing, calculates how much material was worn off, and predicts when the brakes will need replacement. Instead of inspecting brakes on a fixed schedule, airlines only schedule them when the data says it's necessary. That reduces unnecessary downtime and catches potential issues before they become safety concerns. The system also adjusts braking force automatically based on conditions. If one brake is hotter than the others, the computer shifts more braking load to the cooler brakes to balance wear and prevent overheating. The electric brakes are also lighter than hydraulic systems. No heavy hydraulic lines, no reservoirs, no pumps. Boeing claims they reduce maintenance costs by about 30% over the life of the aircraft. So, here's what all 10 quirks have in common. They're only possible because Boeing rebuilt the plane from scratch using composites. The flexible wings, carbon fiber. The lower cabin altitude, a composite fuselage that doesn't fatigue. The higher humidity, no metal corrosion to worry about. The smoother ride, composite wing design, plus the extra electrical power that weight savings unlocked. Even the raked wingtips, the double bubble fuselage, and the LED lighting are downstream consequences of going composite. Boeing saved so much weight on the airframe that they could afford to add features that would have been too heavy on a metal plane. Composites make up 50% of the 787 by weight. That's the fuselage, wings, tail, and floor beams. The plane looks solid, but it's mostly advanced plastic. That's why the 787 can fly further, more efficiently, and more comfortably than anything that came before it. It's not incremental improvements, it's a fundamentally different machine. Boeing bet a lot on this technology. The 787 program cost over $32 billion, a huge risk, especially when production delays spiraled out of control. But it stuck with it, and now every new widebody, Airbus A350, Boeing 777X is following the same playbook. Over 1,200 Dreamliners are flying today, and Boeing has orders for over 1,000 more. The plane that looked impossible 20 years ago is now the backbone of long-haul aviation. Next time you board a 787, look for these quirks. Watch the wings flex during takeoff, hit the window button, notice the ceiling height, feel the smoother ride, breathe the better air. You're flying on the most advanced passenger jet ever built. And those flexible wings, they're not a flaw. They're proof that Boeing figured out how to make physics work for them instead of against them. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?